If you've been watching my videos, then you may recognise this. It's a power supply I built. It's based on the Raiden RD6006 power controller. That's just this front part. I bought the case separate, a switching supply, assembled it. I have made a video about that if you want to look at the assembly and initial testing. I'm building quite a few of these for various purposes. It was originally intended for use in the repair lab, but it has a feature that I don't like, so I don't want to use it with the rare and expensive equipment I repair. So these supplies will remain in the workshop instead, but even so they're still, I believe, extremely good supplies, and I'll be using, as I say, quite a few of them for various testing. As part of the build process for these, I'm starting off making two different versions. I'm making this version, which has a cheap Chinese switching supply in it. I'm also making a linear version. That's a linear back end. Of course, the Raiden unit is still a switching supply, but the linear version should remove all the noise coming from the cheap Chinese switching supply. Despite its small size, this is actually a 360 watt supply, and in order to do proper testing, I always do a very thorough testing of equipment I buy and use, and as part of that I need to run it for extended periods, but I need to run it at different loads, including full power. Now I do have a number of electronic loads, so I'll just give you a quick look at the one I normally use. So it's the REK RK8511. The problem with that is it's only 150 watt, and while I do have other electronic loads, I tend to leave the test running fairly long term, and so I needed to pick up a couple of additional electronic loads so I could test the supplies that I'm building. I also have some other projects coming up where I need a number of electronic loads. Looking around, I found a number of loads that were suitable. I wanted something that was at least 300 watts. And the prices vary, anything from £150 up through well over £1,000. And I only really need something fairly basic. I just need something that will do constant current, constant voltage, constant power and constant resistance. So I had a look around, and I'm quite a big fan of testing out cheap Chinese equipment. If you watch my videos, then I quite often say that people quite unfairly beat up on the manufacturers of these cheap devices. Yes, they're cheap, yes, the quality is not always there, sometimes they're just unusable, but quite frequently they are perfectly usable and a fraction of the price of something you'd buy elsewhere. The quality might not be there, the features might not be as comprehensive, but they can be perfectly usable. So to that end, I decided to try a cheap Chinese electronic load. That is cheaper than the ones I bought previously. So I'll just grab that and we'll have a look at it. So this is the one I decided to look at first. It's a Kunkin, got to be careful how you say that. It's a Kunkin KP184. In theory it should be a 400 watt load, and what I'm going to do is I'll unbox it, we'll have a look at it, and I'll tear it down, we'll have a look inside, and then I'll do a mini review, run it up, see how it works. As you probably know, some electronic loads are a little bit odd in the way they can behave to varying loads, and they can go into the wrong mode. So we'll give it a good run, we'll see what power it can actually handle, and see if it was worth the money I paid for it, which was £135 delivered. So I'll get it opened, we'll have a look inside and see how it looks. Okay, so it's fairly nicely packaged. It comes with an RS232 lead. It is computer controllable. It's got a power lead, but it looks like we've had some unfortunate business with the power lead on this one. The pin is snapped off. Comes with a remote connector and even some power cable for remote sensing. This has got remote sense capability apparently, but we'll have a look, see how well that works. So I've finished getting it unboxed. Okay, we've got some instructions. Let's have a quick look. And they are in English. And having a quick scan through, it does appear to be relatively good English, so this is looking quite promising so far. And this unit is very reassuringly heavy. I'm actually quite surprised. This does weigh quite a significant amount. I was expecting a very lightweight unit, but so far it's looking quite promising. Okay, we've got a crib sheet here. It's in Chinese, so I think that may have limited use. Well, on first inspection, I have to say I'm impressed. We've got a Kunkin sticker. I mean, it's cheap plastic. The plastic feels cheap, but as I say, it is surprisingly heavy. I'm very surprised at how much this weighs. Very nice feeling control. The control itself, the knob itself, is cheap, but the actual feel of it is very good. Some quite nice terminal posts on this, and also one thing I do like is you can use a 4mm banana plug on these, which I can't do with my other electronic loads, and that's one of the things that does bug me with them. It says on here 150 volts, 40 amp max. So you can see here it's got the remote sense input, so if you want to have this monitor the voltage at the remote device that you are testing, then you can do that, and it just lets you eliminate the losses in the power leads. Okay, it's actually very nicely finished. All the so far the metal work very nicely finished. No sharp edges. I don't know if that's somebody's blood or not, but let's hope not. Okay, so what I'll do, I'll get the cover taken off and we'll have a look inside before we try and power it up. I'm sure that's something that Dave would approve of. Okay, I believe that's all the screws out, so I think this should just slide off. So a very nice solid piece of metal work. So again, all the metal work is nicely finished, no sharp edges, which is quite unusual. The circuit board looks surprisingly good. It's actually a very high quality board, which again I'm quite surprised by. And there's another board on the bottom, which again is a good quality board. Right, that's loose. That's the first negative thing I've seen, so I will tighten that. It's just those screws on the bottom aren't tight enough. And of course that means that also the earth lead is loose as well, so that needs to be sorted out. So I haven't tried plugging this in yet. Okay, the display and control board is also good quality, so all the boards are very good quality boards. I'm not going to do a full review of this. I'm not going to look at the board in depth. Let's get the light down so you can see it a bit better. But if you want to look at it, fairly obvious how this works. We've just got some power FETs. these, and so it's a relatively simple design. Ah, there they are. I was looking for the other power devices set on the bottom of the heatsink. Okay, integral fan. Don't know how noisy this will be. Very beefy current shunt we've got up here. So that's looking quite promising. Everything seems to be done up nice and tight, apart from the transformer. Make sure we're on the right voltage, which we are. Has also got this input output block on the back, so you can see here what's on that connector. We've got RS485 trigger, 12 volt pass fail, so this is where you set limits, and this will allow you to use this as a pass fail tester. Not quite sure what 1 and 2 are yet. I'll look at the manual later on. And of course we've got RS232 control over this, so it's quite a nice load in terms of the features it has. On the board we do have marked TX and RX, so it's possible we've got, in fact it does say it's a JCOM connector here, so it is possible, and again looking at this header, that it might be possible to hack this. I'm not going to bother trying to do that unless I have a particular need to. But so far looking surprisingly good. I have to say I am so far impressed. So what I'll do is, so it's pushing all the way on, so we've got a mains connector not pushed all the way on. The soldering looks good quality. We've got some gunk holding the connectors in, so that stops them falling out. That's on all of them. So far, I'm impressed. Compared, or considering what I paid for this. So what I'll do, I'll get the transformer tightened, I'll get the cover back on, and then we'll give it a run and see how it works. I don't want to run it with the case off. Obviously we need to make sure it's a proper test. I want to make sure the air flows where it's supposed to. And if we get any problems with it, I'll take it apart again and we'll see what failed. Okay, I've got it all connected up. I've connected the ride and supply directly to the electronic load, and then I've got the adjutant connected directly to the terminals of the load, because it's the load I'm testing here and not the supply. So first thing I want to do is power it up and see if it actually works. Okay, it's a very nice bright display. Unfortunately I can see that it's flickering on the camera. Unfortunately there's nothing I can do about that. Because of the type of camera I have, its frame rate varies depending on what's on the screen, so I've got no way to set the frame rate to prevent it from showing flicker. If I set it to a particular frame rate, then it may start flickering again if something else comes onto the field of view. So sorry about that, hopefully it won't be too annoying. First thing I'd say is very nice display, nice and bright. The only thing is the illumination for the symbols is not in quite the right place. If your eye line isn't directly in front of the display, then only part of the symbol is illuminated. Having said that, you can still see which one's illuminated, so it's not a big problem. It'd been nicer if the LEDs behind were a bit further forward. Okay, so what we'll do now is, I'm not going to do an in-depth test of this. I'll come back on another video and do a review of this if you want. If you want to see a proper review of this, let me know. I'll come back and do an in-depth one. For this I just want a load that will allow me to test these supplies at higher power for extended periods of time. So what I'm going to do here is I've set the Raiden up to its maximum output, 60 volts at 6 amps. And what I'm going to do is run it in constant power mode. So I've got the electronic load set to constant power, and what I'll do now is power up the In fact, what I'll do first is set the power limit. So that's set to 1 watt. I'll set that up to 10 watts. So we're on 10 watts. And what I'll do is power up the Raiden, and we should get 10 watts indicated on the electronic load. So fairly close. Output from the Raiden is showing as 60 volts. That's at the electronic load, which is very close. It's actually showing 59.97 on the Raiden display, and the Agilent is calibrated, so it should be extremely close. And this is very close to what the electronic load is showing. Haven't looked at the full spec for this. I'm not sure what the resolution is for measurement, but it's not what I intend to use it for. It's not critical, it's just to test these basic supplies. So I'll start increasing the power. We'll keep an eye on the Raiden to keep an eye on the internal temperature and see how the power output continues to rise. At the moment you can see it's showing 10.1913 watts. This will of course be lower on the load because we will have an increasing loss in the cables, so the voltage of the load won't be as high as it is at the power supply. Won't be a great deal, but it will be slightly lower all the time. Okay, so I'll start to increase the power of the electronic load limits. So up to 20 watts, and it's looking fine so far. Voltage is still showing pretty much the same error it was before. It's about 20 millivolts or so, so it's quite close. I'll keep going up. So we're at 30 watts. I will do some more in-depth testing later, measuring the current. I don't know if the Raiden's optimistic or the electronic load is under reading, but the current on the electronic load is showing as much lower than the Raiden is indicating, so I'll test that. I have tested the current output on the Raiden and it was indicating fairly accurately, so I'm assuming this error is actually in electronic load, but I will measure that later on. Up to 40 watts. So currently we're at 60 volts still, about 700 milliamps. The internal temperature of the Raiden's still fine, the fan hasn't kicked in yet. We'll keep going up. 50 watts. The input voltage to the Raiden controller, as you can see, is still up at 64.85 volts. That's still looking quite good. We'll go up to 60 watts. Okay, still looking quite good. The voltage is still accurate, and bear in mind we are measuring the voltage at the terminal post of the electronic load and not at the output of the Raiden. Okay, we'll keep going up. We'll go up to 80 watts. So it looks like we've got a constant offset in power here of about 2 watts, so that could be down to the resolution of measurement of one of the two units, most likely the Raiden, but I will test that later on. Currently we're up about 1.4 amps at 60 volts. The internal temperature on the Raiden has gone up by 1 degree, so that's quite promising. We'll go up to 100 watts. And the fan on the electronic load hasn't kicked in yet either. Now obviously we've lost a decimal place on the power reading on the Raiden, but it's still showing roughly the same error it was before. It's overreading by about 2 watts. Okay, we'll go up to 120 watts. Very loud beep on the electronic load. Incidentally, I turned the beeper off on the Raiden, but I also put a bit of tape over the sounder, and I'll probably do the same thing on the electronic load. It is annoyingly loud. Okay, so it's looking quite promising. The internal temperature of the Raiden is starting to rise. It's gone up by another degree, so we'll go up to 150 watts. see the input voltage going into the Ryden has dropped very slightly. It's down to 63.74 volts. The power is starting to come down nearer to what the electronic load is reading. So it was over 2 watts error. It's now only 1.3, 1.4 watts. So currently we're at about 60 volts still, at 2.5 amps, and the internal temperature of the Ryden is risen 3 degrees. It's rising very slowly, but it's still around 27, 28 degrees. The fan on the electronic load hasn't kicked in. Now this is the limit of my normal electronic load. That's as high as I was able to take it. To go higher than this testing the Ryden, I had to use a less accurate electronic load. So now we'll see if this can keep tracking up, and later on I will test the accuracy of the load and see if the power it's indicating is correct. But so far it's looking quite good. The voltage and the current are very close to what is being indicated by the Ryden supply. So I'll go up to 175 watts. So far the electronic load has been very easy to use. It's very intuitive. It does have a menu system apparently, which I'll look into later. As I say, if you want a full review of this, let me know and I'll do a detailed review. This is just very basic testing to see if it's going to be suitable for testing these Ryden supplies. So up to 175 watts. The fan on no, the fan has kicked in yet, so they're still looking quite promising. The temperature of the Ryden is continuing to rise. It's now up to just coming up to 29 degrees, but that's very acceptable. So that temperature on the Ryden is indicated from the hottest part of the switching supply, and so that in theory is the hottest part of the system. Okay, I'll go up to 200 watts. Okay, we're at 200 watts, just under 60 volts, and we're at around 3.3 amps. Quite interestingly, the voltage going into the Ryden supply has gone back up. It did drop to around 63.5 volts. It's now back up to 64.7, so it's quite strange. I'm assuming that's something to do with the way that the switching supply that's in this unit works. Okay, the temperature is starting to rise a little bit faster now. It's up to 30 degrees, but again that's perfectly acceptable. The fan on the Ryden hasn't yet kicked in, and neither has the fan on the electronic load. Of course it is possible it's not working, but that's the point of this test. Okay, having said that, the fan has just started up. I can hear it. It's very quiet, but I'm assuming it will speed up as the power goes up. So we'll go to 250 watts. It's got a very nice speed control on the adjustment. Seems to be about the right rate, goes up nicely, but it's still controllable. Obviously you can't type in a number, that's the only downside, but that's not a big issue. So now we're at 250 watts. Notice we're only about 0.7, 0.6 watts error showing between the Ryden and the electronic load. And the temperature in the Ryden is now up to 31 degrees. Okay, I'll take the power up to 300 watts. And the fan in the electronic load is now starting to speed up. The air coming out of the load is fairly warm. No weird smells or anything, so it's still looking quite promising. The temperature of the Ryden is of course continuing to rise. And its fan is also starting to kick in. You can hear both fans starting to speed up. I'll go up to 350 watts. So we're at 350, getting close to the limit now on the Ryden. So I'll take it up to the full 360. Okay, and the Ryden is starting to complain. So the current limit is kicked in. It doesn't appear as if though it is going to recover. Okay, interestingly the Ryden wouldn't recover until I disconnected the external load. What I'll try doing to get to the full output power is I'll increase the current limit on the Ryden to 6.1 amps, and we'll try going back up to full power again. Okay, so it does appear there's a bit of some strange behaviour if it does go into current limiting at very high powers. The input voltage to the Ryden is still up over 64 volts, so that's fine, and the temperature internally of the Ryden is 34 degrees. We'll leave it going for a while and see if anything gets particularly hot. So we've now got just under 60 volts and 6 amps, actually showing quite accurate readings on the electronic load. It's very close to what the Agilent is reading, so we're getting 59.85 on the Agilent and 59.84 on the electronic load. The air coming out of the electronic load is now quite warm, but I can hear the fan continuing to ramp up. The temperature in the Ryden has now risen to 36 degrees, so it's starting to get quite warm, and its fan has increased. It's going quite fast now. Neither one's particularly noisy. In fact, if anything, I'd say that this electronic load is quieter than the other loads that I have. In fact, those loads do tend to make annoying noises depending on the power that they're handling. Whereas this, I can't hear any of the switching noise at all. All I can hear is the fan, and that's very acceptably low. Okay, we're still up at around 36-37 degrees in the Ryden, and the fan has gone up another notch on the electronic load. I'll leave this running for a while and see what happens. Okay, it's been going for quite a long time now. It's about 30 minutes. What's happened is the Ryden got up to about 39, just over 39 degrees, and the way I have the fan set up in the Ryden, there are two fans. There's the one on the Ryden controller itself, and we heard that kick in fairly early on. The temperature that's indicated on the front, which as I say is on the hottest part of the switching power supply, went up to a little over 39 degrees, and the way that the Ryden works is it will use that temperature to control a cooling fan, and the main cooling fan on this unit is the one that I fitted to the back of the case, and that kicked in a little over 39 degrees. The temperature has since remained between 38 and 39 degrees, so it's just leveled out. 38, 39 degrees, that's perfectly acceptable. The outside of the unit is a little bit warm on top, but only barely. It's just barely lukewarm, and it's quite cold at the back. I can't feel anything else getting hot. The electronic load is quite warm, as we'd expect, and there is a lot of very hot air coming out the back. Again, to be expected, so it will need plenty of ventilation around it, but it's fairly quiet. It's not an unpleasant fan noise, it's not intrusively loud, and just sat there very stable, hasn't done anything strange. I'll now leave these running for a few hours, make sure they behave themselves, but so far it's looking like the electronic load is going to do exactly what I need it to. So it may well be, in this case, it's £135 well spent. As I say, if you want me to do a full review of this electronic load, then let me know. We'll check its performance, see how well it goes, see what control we have through the RS232, and what other menu options we have to play with, and also maybe look at using the remote sense input. The connector that comes with it doesn't have any leads attached. It does have some connectors, but so far I've got to say I'm very impressed. The only downside is just a very minor one, that it had a broken mains cable, but as I say, I wouldn't have used this anyway. But the odd thing is the broken piece is not in the box, so I can only assume this was put into the box broken, which is a bit of an oversight. But maybe something they need to look at in terms of their packaging. The packaging was quite good, so it does seem quite strange that was broken. As I say, I think it was broken before it was put into the packaging, so this is looks like it's more an inspection issue rather than packaging or shipping. So far I'm very happy with the purchase. It does appear to be very good value for money. If it continues to perform like this in the other modes, then that's everything I need it to do. If you have one of these, if you've had any problems with it, then please leave a comment.